Hello everyone. In today's session, we will be discussing about finite state machine as a string validator. In the previous session, we had seen FSM as a string validator for checking whether a particular string ends in some type of pattern. In today's session, we will be seeing whether the string contains some type of substring to validate the input in our FSM. So let's begin. Design finite state machine in which the input is valid if it contains 1011 over the input 10, 1. Now here we can see the word contains, whereas in a previous session we had seen the string validator for ends in type of question. So here we will try and understand what exactly is the difference between ends in and contains. In ends in, we have to scan the complete input string till the end of the input and it will be checking for each symbol. Whereas in contains, as soon as the first occurrence of the given substring is found, the rest of the input string will be scanned but will not matter what is the input string. So let's begin the solution. As usual, step 1 is theory, that is definition of finite state machine. Step number 2 is logic. I is already given in the question, the set of 0, 1. O will remain y, n, that is yes and no. And finally, S as states Qs to Q4, where Q0 will represent 0, Q1 1, Q2 will be 1 0, Q3 will be 1 0 1, and Q4 will be 1 0 1 1. Step 3 is implementation. So as seen in the table, we have I, that is 0, 1, and states Qs to Q4, where Q4 will be our final state and Qs is our start state or initial state. When we are in Qs, as soon as I get 0 and 1, I will reach Q0 and Q1 state respectively. In case you are still not comfortable understanding why it is Q0, Q1, you can visit the previous video sessions and get it cleared. When we reach Q0 state, we get the string as 00 or 01. We do not have either of the states represented in our table, so we will go to Q0 and Q1 state. When we reach Q1 state, the next input symbol that we get is a 0, it becomes 10. So we have a state representing 10, that is Q2 state. So we will reach Q2 state or else stay in the same state if the next input symbol is 1. Similarly, for Q2 state, we have 100, so we will be reaching Q0 state since there is no state representing 100 or 00 or we have only 0. And for 101, we will reach Q3 state. Finally, for Q3 state, we have 1010, so we will reach Q2 state, and 1011, we will reach Q4 state. And for Q4 state, as soon as we reach Q4 state, we would have reached or found our substring 1011. So we will stay in the same state. Okay. So this Q4 state is also known as trap state. Now trap state is nothing but the final state of our machine which when gets self looped. Okay, just like our contents question, we will stay in Q4 state itself and not come out of that state because we do not have any other state to go to from Q4 because the question said that we have to find the string 1011 at the first occurrence. So that is why as soon as we find 1011, we will reach Q4 state and stay there itself. So it is also known as a trap state. For MAF, again the pattern will be followed, that is wherever there is a non-final state the output will be no, and for final state the output will be yes, that is Y. As I said that In the state transition diagram, a state transition table, the values which were written in the bracket are just for our understanding. As we can see through state transition diagram, each transition has only single bit that is being scanned by our machine. So that is just the representation for our state transition function to write down the states that it should alter to. Now let us begin with the example. Let us take QS, 0110. So what will happen? From QS, it will transit to Q0, from Q0 to Q1, from Q1 to Q1, and from Q1 to Q2, giving us the output as no, that it is not a valid input. Next, QS, 011011. So here what will happen? It will transit to Q0 state. From Q0 it will go to Q1. From Q1 it will stay in Q1. Then it will transit to Q2 state. From Q2 state it will go to Q3, and from Q3 it will reach Q4 state and give us the output yes, it is a valid input. Let us take another example. Design finite state machine in which the input is valid if it contains at least one occurrence of substring BBA over the input A, B. So here in the solution, step 1 will be theory, that is definition of FSM. Step 2 is logic, having I already given A, B. O will be Y, N, and here S will be from QS to Q3. So Q0 representing A, Q1 B, Q2 BB, and finally Q3 BBA. For the table, we have I as A, B, that is A and B, and for S we have QS to Q3. Here Q3 is again our final state because that is the state representing the substring BBA. That is what we have to find in our given input. From QS again we will be going to Q0 and Q1. From Q1 we will go to from Q0 we will reach Q0 and Q1 respectively. From Q1 we will have BA and BB. So for BA we will go to Q0 and for BB we will reach Q2 state. From Q2 we will go to Q3 state on getting A as the next input, and for BBB we will stay in the same state, that is Q2 state. And finally for Q3 we will remain in the same state, which is again a trap state, so that once it finds the first occurrence of BBA, we will not be concerned about the rest of the input string but still scan till the end of the input string. For the MAF, we will be following the same pattern, that is for non-final states the output should be no, and for final states the output should be yes. The state transition diagram will be somewhat like this, that is from QS we go to Q0 Q1, from Q0 Q0 Q1, from Q1 to Q0 and Q2, from Q2 to Q2 and Q3. From Q3 we will be staying in the same state because here it is a trap state, as we are not concerned with rest of the input string other than BBA. So here the pattern is getting formed BBA. BBA. Let us take an example. ABB. So here from QS we will go to Q0. From Q0 we reach Q1. From Q1 we will reach Q2. From Q2 we will reach Q3 and stay there and give the output yes. Let's take another example. ABA. From QS we will reach Q0. From Q0 to Q1. Q1 to Q0. Q0 to Q1. Q1 to Q0 and giving the output no. So finally, as we can see that for finding or questions, that is ends in and contains, have two different patterns that we need to take care of by depending on the question mentioned. In case you have any questions or any queries, you can just leave it in the comment section and we can resolve it in our next session. Thank you.